يعطيكم العافية شباب، إن شاء الله كلياتكم بتكونوا بخير وصحة منيحة. نحن هنستغل وقتنا ونشتغل بهالفراغ function. الجزء اللي يفضل علينا هو ما يخص الأوبليك asymptote. اليوم رح نشتغل exercise ونعمل training ننشط ذاكرتنا شوي. Exercise given f of x equals x minus 1 plus 4 over x minus 2. The domain of definition is minus infinity to union 2 plus infinity. First question is calculate the limit when x approaches to 2 minus 2 plus of f of x and deduce the asymptote. Okay? فإذا limit when x approaches to 2 minus of f of x is equal to limit when x approaches to 2 minus x minus 1 plus 4 over x minus 2. We can replace x by 2 minus 1 plus 4 over, in the denominator it's 2 minus. 2 minus, I mean it's a number approaches to 2 but x less than 2. So it's 1 plus 4 over 1.9 minus 2. So it's 0 minus, so we obtain minus infinity. Limit when x approaches to 2 plus of f of x, same but 1 plus 4 over 0 plus, so it's a plus infinity. We remark that when x approaches to 2 minus, we obtain minus infinity. When x approaches to 2 plus, it's plus infinity. So x equals 2 is a vertical asymptote. Part 2a, calculate limit when x approaches to minus infinity of f of x, limit when x approaches to plus infinity of f of x. Limit when x approaches to minus infinity of f of x, it's a simple replacing by minus infinity minus 1, okay, plus 4 over minus infinity. We know that the number over infinity is equal to 0. So minus infinity plus 0, it's equal to minus infinity. Limit when x approaches to plus infinity of f of x, it's equal to plus infinity plus 4 over plus infinity, it's equal to plus infinity plus 0, it's equal to plus infinity. We know that we have two types of asymptote. If the asymptote is vertical, and the second one is when the asymptote is a horizontal line. But in this case, in the first part, we have limit when x approaches to number. This number is 2 minus or 2 plus. We obtain minus infinity plus infinity, so x equals 2 is a vertical asymptote. When x approaches to plus or minus infinity, we don't obtain a real number, so we don't have a horizontal asymptote. So now we have a question in part B. Prove that the line of equation y equals x minus 1 is an asymptote to C. Okay? This line is a relation between y and x, so it's neither horizontal line nor vertical line. It's an oblique line. The rule is if limit when x approaches to plus or minus infinity of a function f of x minus y of d equals 0, so the line d of equation y equals ax plus b is an oblique asymptote. Okay? We have to apply this rule to solve part B. The question is, prove that the line D of equation y equals x minus 1 is an asymptote to C. We can solve this part using two steps. First one is to find the subtract between f of x and y of d. F of x minus yd is x minus 1 plus 4 over x minus 2 minus x minus 1. By simple calculation, we can cross the opposite terms, and now we obtain 4 over x minus 2. Second step is to calculate the limit of this answer as x approaches to minus infinity and x approaches to plus infinity. When x approaches to minus infinity, it's 4 over minus infinity, it's 0. Limit when x approaches to plus infinity of 4 over x minus 2 equals 4 over plus infinity, also it's 0. Using this rule, we can deduce that the line D of equation y equals x minus 1 represents an oblique asymptote. Part C, we repeat. To prove that a line represents an asymptote, we remark that this line is a relation between y and x, so I'm sure that it's an oblique asymptote. We have two steps. First one, we calculate the difference between f of x minus yd, so we obtain this answer, and we calculate the limit when x approaches to minus infinity and the limit when x approaches to plus infinity of this answer. If we obtain 0, so this line represents an oblique asymptote, okay? Part C, study the relative position of C and D. To study the relative position, also we have to use the difference between f of x and y of d. F of x minus y of d equals to 4 over x minus 2. Now we have to study the sign of the answer. 4 is positive. What is the sign of the expression x minus 2? To find the sign of x minus 2 is a factor in the denominator. So we solve it different than 0. X minus 2 is different than 0, then x different than 2. And we draw a table of sign containing the domain of definition of the function minus infinity, plus infinity, and 2. 2 is rejected, so 2 is shaded. Using grade 10, x minus 2 is a factor whose coefficient is positive. After the root, same sign of the number multiplying x, so it's plus, and before it's the opposite sign, so it's minus. When f of x minus yd is positive, so c is above d. When the sign of f of x minus yd is negative, so c is below d. اوكي يا اخوان؟ طيب